Hello students. So we're going to go today over 7-3, which is similar triangles. So in 7-3, that is in 7-2, we talk about similar polygons and what constitute to be similar, and we understand that similar means that it's going to be same shape but different size. In order to have the same shape, you will need it to have congruent angles, but you need it also to have proportional sides, and you will have to evaluate all the sides. Today we're going to go in depth with what is similar triangles, and there are going to be three kind of like quick, easy ways to say that triangles are similar, that two triangles are similar. So when we were working with congruent triangles, we understand that an AAA is going to be similar, not congruent. So basically, that one is right here. This is the first one. Instead of saying AAA, now we're only saying AA, but that is similar triangles. Now, what is SSS? In order to triangles to be similar SSS, you will have to evaluate all three sides to both triangles and hold the same proportion between all the sides. And that will tell you that those two triangles are similar. And last, you will have SAS. SAS says that you can evaluate two sides of the two different triangles, see if they hold the proportion between both of the sides, okay? But the angle containing the middle of the two sides will have to be congruent to the other triangle. So when we look at the example number one, and we pay attention to this sample number one, we'll look and we say, okay, they're trying to see if the left triangle is similar to the second triangle. And they start evaluating, okay, so 9 and 6, they put it over here and they check for the ratio 2/3. We're good. 8 to 12, they put over here 2:3. We're good, okay? So basically you have two of them that are proportional. And then you check 10 to 15 and you will look and say, okay, so these are proportional. So now I can say triangle ABC similar to triangle DEF. How it is that I know this? Because SSS similarity. Remember, order matters. So ABC similar to DEF. When we look at sample number 2, then you're missing one of the sides, but you have two other sides, and you have the angle containing between the two sides. So they basically do the same, and they see if the ratio holds. So 3:4, just like 6:8, and the ratio will hold, okay? And they will say that they have the same proportion, and then they look, okay, angle N is congruent to angle R. So basically these two triangles, and they again, order matters, N and P to RQS, those two triangles are similar by the SAS similarity. So when we look at these samples, they're asking us to say whether the triangles are similar or not, and then we need to say how it is that we know that they are similar. So we'll look at sample number 1, and are these two similar? Well, let me see. Angle A is congruent to angle D. How do I know? Because of the marking. And then I look and I say, well, angle B is congruent to angle E. How do I know? Again, because of the markings. So I have two angles that are congruent. That means C and F are also congruent. Therefore, these two triangles are similar. I can say, yes, these triangles are similar. Okay. How it is that I know? Because of AA, similarity. And then I need to write the similarity statement. So I will have to write something like triangle ABC similar to triangle DEF. And that's it. Simple as that. We go again and we'll look. Okay, so for this one, what do we have? Well, we have two sides and we have an angle in between. So the angle in between, we're good. The angle in between is a right angle and a right angle. So basically checks out fine. Now let's check for the sides. And again, order matters. I'm going to tell you to pay attention to the sides. I want you to look at the 18 and the 24. Which one is the short? That's the short. Which one is the long? That's the long. And this is the short and that is the long. So I'm going to say 18 is to 20, like 24 is to 36. So let me see if this holds. So I will say 18 is to 20, just like 24 is to 36. Now, if I put this in the calculator and I have the same number, then I will say these two triangles are similar. So I go 18 divided by 20, that gives me 0.9. Then I say 24 divided by 36, that gives me 0.66. So these two numbers are not the same. This number and that number are not the same. Therefore, I will say, no, these two triangles are not similar. Not similar. So what do we have over here? Okay, so if I remember correctly, I have a line, and that line is being intersected by two lines that are completely parallel. Therefore, I can completely say that that angle is congruent to this other one, while this other angle is congruent to that other one. So now, if I look at the small triangle, let me make another mark right here. 1, 2, 3. If I look at the small triangle, I will see it has the blue angle, it has the red angle, it has the green angle. Let me check the big triangle. So the big triangle has the blue angle, the red angle, and the green angle. So just by looking at the similarity, all of these angles are congruent. Therefore, these two triangles, the small one and the big one, are congruent. And remember, order matters. So I will have to say triangle, and we'll say R U T, similar to triangle S L T. How? AA, similarity. Let's take a look at number 4. Okay, so number 4, what are the things that I have? I have two sides, and I have an angle in between the two sides. So most likely, this is going to be SAS. I see that the two angles are congruent. That checks out fine. Now we need to see if the ratio holds. So I will say that side is to this other side, just like that side is to this other side. And we check and we say, okay, 8 is to 4, and 8 divided by 4 is 2. Just like 18 is to 9. 18 divided by 9 is 2. So we can see it holds. So I will say, yes, these two triangles are similar. I will say, but I will have to say, okay, triangle, let's say DKJ, similar to triangle PRZ. And how it is that I know? SAS similarity. Okay, let's take a look over here. Are these the same? Well, let's go again. It looks like it's the same type of situation that we had before. I have, let me see if I can understand this. I have short side and I have long side, short side, long side, and I see that the angle in the middle checks out to be congruent. So let's say that short is to short, just like long is to long. So we're gonna say 24 is to 16, and we go to the calculator and we check. 24 divided by 16 is 1.5, and then we go blue and we say blue 39 is to 26, and we go to the calculator again. 39 divided by 26, 1.5, and checks out fine. So these two triangles are congruent, or are similar. These two triangles are similar, okay, by SAS. I will say, but I will have to write, okay, so triangle FBE similar to triangle LNM. SAS similarity. Let's see. Okay, so this time I don't have, whoops, I have no idea what happened here. Okay, here we go. This time I don't see any angles being marked, so I don't know if they're marked. So all I have are the three sides. Do they hold? Well, let's see if they hold. I will say short, medium, large, short, medium, large. So let's do that. Let's see. Short to short, medium to medium, and then large to large. And we begin and we say, okay, so 24 to 15, I will have to say 32 to 20, and then I will have to say 40 to 25. So let's see if all this holds, if they have the same proportion. And if they have the same proportion, all of them, then I will say, yes, these two triangles are similar by SSS. So let's start by 24 divided by 15. We have 1.6. Let's say 32. 32 divided by 20. 1.6. Is that enough? No, that is not enough. I need to check all three sides. So and then I will say 40 divided by 25, 1.6. So now I know, I definitely know, these two triangles are similar. Okay. But now I say, okay, so let me write the similarity. Triangle, I'm going to say GHI, similar to triangle QRS. And this is SSS similarity. But now, we need to do some algebra. You know me, I have different ways of doing algebra. I can tell you right now, so I can tell you that these two triangles are similar. I'm going to tell you that, okay? So we need to identify how it is that they're similar. In other words, a triangle, blah, 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 similar to triangle, blah, blah, blah. This is what they're asking us to write, okay? So these two triangles are similar. And then the other thing that we have to do is we need to find what X is. So to do this, I just want you to do not stress yourself, okay? Try to make it as easy as possible. What do you have? Look at what you have. So you have one marking, the right angle, and the no marking. So So I would say 13 is to x, just like 10 is to 20, right? And I can write the equation, and I will say, okay, so 20 let me see if I can write it. 20 is to 10, just like x is to 13. I can go 10x equals, I'm trying to get the calculator here to work. Where is the calculator? Where's the calculator? There it is. Too big. Okay. And then I will say 20 times 13. 20 times 13 is 260 equals 10x divided by 10 divided by 10, x equals 26. So just like that, all you have to do is find whatever x is, and then just basically either like that, find, cross multiply, or the other way that you could have done this is understand that 20 is to 10. So basically this is the proportion factor, okay, or the scale factor, so h2. So all you had to do was take the 13 and multiply it times 2. Okay, so I will say this is the factor, okay, is the 2. So again, you could have taken 13 and multiplied times 2. Now we have to write the similarity. So triangle XZY, it's similar to triangle JLK. Right, let's go to problem number 2. And let's see if we can simplify this a little bit. We'll look and we say, I see a small triangle. I see a big triangle. I see that the small triangle is isosceles. I see that the big triangle is isosceles. Okay, I can definitely say that angle is like this other one, and I can say that basically it's the same angle. That angle is that other same angle like here. Okay, and then we have a third angle right there. I will say that the long side, the big triangle, is this big. Okay, and that will be a 26 plus a 13. So that will be 39 is the big, while the short side is just 26. See? So I will say, okay, so big is too small. Okay, so big is too small. I will say 39 is to 26. Okay, and I can put that in the calculator. Okay, I will say 39 divided by 26. That gives me 1.5. So here is the factor. 1.5 is the factor. Okay, so now I need to find x. Well, if I take 20 and I multiply times the factor, I will take the 20 and I'm going to multiply times the factor 1.5. That is going to give me the big side, which is x. So I go to the calculator, 20 times 1.5, and that is 30. 30. So x equals 30. Just by finding the factor. Let's see over here. What do we have? Well, I can tell you this is a little bit too simple. And why is it too simple? Well, let me show you this. You see, you have a triangle, big triangle, and the big triangle over here is an isosceles triangle that we know. So, and if it's an isosceles triangle, that big triangle right there, right? Then this side is 24. You know what this other one is going to be? 24. Okay? So, I'm going to take a guess right here, and I will say x is pretty much whatever is 36 minus 24. But let's check with the ratio. So the long is going to be 36, right? Well, yeah. You know what? There's no point in doing this. 36 minus 24, and that's it. 36 minus 24. Okay, so that is 2, and that is 12. Ladies and gentlemen, QR is just 12. This is just 12. Okay, and that's basically it. So now I need to establish the similarity. I will say STR is like SVQ. So let me write that down. Triangle STR similar to triangle SVQ. And we're done with that one. Let's move on to something a little bit more challenging. Okay, so what do I remember? I remember that if I have parallel lines and then I have a transversal, I will end up with an angle over here congruent to an angle right there. And if I have, again, two lines cut by a transversal like so, I will end up with an angle over here congruent with an angle right there. Okay? And I know that this angle is a vertical angle. That we know. Okay? So I'm going to start by saying that triangle, I'm going to say it like this. C, B, A, similar, and I'm going to say green, blue, red, similar to triangle green, which is E, blue, red. Right? So now the next question is, what is X? Okay, so I want you to look at X. X is in between B and C. Okay, let me get another color here. This one, this is the one that we want to find. And it's in between B and C. So it's right here, in between B and C. So I look that it's in between B and C. What number do I have in between E and B? Okay, so what do we have? We have 38.6, right? So X will be to 38.6, just like, I don't know, but I need to find another number. So I'm going to pay attention to the big triangle over here. I have that number down, which is fine. But now what is the other possible number that I have over here? I have a 30, right? So if I have a 30, let me get another color over here. Let me take this one. Oh, no, a 30, no, it's 60. Sorry, this is what I have. I have the 60. And the 60 is in between E and D, right? So what is in between E and D? 60. So what is correspond to that one? Whatever it is in between C and A. And what I have over there is the 30. Wow, will you look at that? I see 60 and I see 30. I see that the number on top of 60 is half of 60. So that number is half of the bottom one. You know what this number is going to be? That number is going to be half of whatever 38.6 is. So I'm going to go to my calculator. Okay, and I'm going to say 38.6 divided by 2. and that gives me 19.3. So I know x is 19.3. Or you can just cross multiply and you will end up with the same answer. Okay, so what do we have over here? Well, a little bit of logic tells me that I have a triangle. I see parallel lines. Therefore, if I have parallel lines, I will say that angle is congruent with that one. I will say angle K is congruent with this other angle right there. And then I have the third angle right here. Let me take a look. I see 8. And I see that 8 is half of 16. I see, so 8 times 2 will give me 16. I'm going to say 9 times 2 is going to give me whatever x is. So the factor over here is going to be 2. And I say x is going to be 18. X equals 18. What is the similarity? Then I'm going to say triangle. Let's go VMK similar to triangle PML. Right? Now, this might be the most challenging one yet. I want you to pay attention over here. I want you to take a look, okay? And people do not assume that because this one is 10 and that is 30, this is going to be, I don't know, 1/3, but, you know, maybe. So let's do this one completely proper, because these two triangles are not, this triangle is not an isosceles triangle. So these two angles are not, you know, congruent. Even though that one is congruent to this other one, but this one is completely different from the green ones. And then, of course, you have the third angle right there. So let's evaluate this a little bit, okay? And I'm going to say long side is too short. I'm going to take short as pink, that one. So what is the long side? The long side is 40, and the short side is 30. So I will say 40, which is the long, is to 30, just like to the other side. I have the long is going to be all that. 32 plus x is to the short of the other side, which is just the 32. So for this one, I mean, we can do a little bit of cross multiplication. Let me write it up here so that we have a lot of space to work with. And we say 32 times 40 equals 30 times 32 plus x. Let me take out the calculator and move it to the other side. Pay attention right here. And we say 32 times 40, that gives me 1,280 equals 30 times 32. That gives me 960 plus 30x minus 960 minus 960. So 1280 minus 160 give me 320 equals 30x divided by 30 divided by 30. X equals 10.66, or I would say 10 2/3. equals x. So either way is completely fine. Okay, and we found what x is. Of course, let's write the similarity. I will say, how about if we say green, blue, red, as in green, blue, red, similar to green, blue, red. So I'm going to write triangle NPF similar to triangle RQF. All right, let's do the last problem. We have the height of two vertical posts are 2 meters and 0.45 meters. Okay, when the shorter post casts a shadow that is 0.85 meters long. What is the length of the longer post? Okay, so this is the short shadow. We want to know what the long shadow is going to be. Well, let's start over here by getting the proportion between these two. So that is extremely easy. You just say 2 divided by 0.45. That is going to give me the factor that I need. So 2 divided by 0.45 is going to be 4.44. Okay, this is my factor. Now if I take that factor and I multiply times the short shadow, it's going to give me the long shadow. So the short shadow, let me take a look where it is. Short shadow is 0.85. So I'm going to take 0.85 times the factor 4.44. Okay, 0.85 times 4.44. That equals 3.774 meters long. Is going to be the meters. Is going to be the long shadow. Ladies and gentlemen, that is the end. And now it's time for practice problems. Good luck.